Okay, so we got Unit 1, Day 3, and this one's called Solving Equations Number 1. Day 4 will be Solving Equations Number 2. So we're going to start out with a simpler types of these problems and get a little bit more difficult tomorrow. So learning target 1, I can solve equations with a variable only on one side of the equal sign, and I can use the distributive property. So you probably maybe remember hearing of the distributive property. We're going to go through that again. To solve an equation, we need to isolate the variable. Okay, so we need to isolate it. Which means you need to get the variable by itself on one side of the equal sign. To do this, you have to move the numbers on the same side of the equal sign on the opposite side. We're going to move everything over to the opposite side by using the inverse operations. Okay, so inverse operations here. Addition, if I said take how much money is in your pocket, now add 6 to it. To undo that, you need to subtract 6. Or if I said take 6 away from what's in your pocket, to undo that, I'd have to add 6 back to it. Or if I said take the amount of money you have in your pocket and double it, take it times 2. To undo that, you'd have to divide it by 2. Okay, and so on in division, multiplication. So these are all inverse operations of each other. Okay, so the first problem here, my goal on this guy right here, my goal, I don't know if this helps at all to draw double lines like that. My goal is to get x by itself here. I want x on the left side by itself. I want everything else on the other side. So for whatever reason, somebody added 6 to the value of x. And when you add 6 to that, or you think of how much money you have in your pocket, when I add 6 to it, now I have $11. We're trying to figure out how much money did you have originally. So we're going to undo that by subtracting 6. But whatever you do to one side, you got to do the other side. So we're going to subtract 6 from the other side. So over here, I've got x plus 6 minus 6. Well, the result is just x. Because if you add 6 and then subtract 6, you get what you started with. On the other side, I got minus 6, which is 5. Okay, so x would equal 5 on that one. Over here, got a little bit more going on. Okay, we took some value, we quadrupled it, and then we subtracted it from 3. And that gave us negative 17. I want to undo all that stuff. Okay, so if you think your order of operations from yesterday, PEMDAS, when you're simplifying, you want to go down. For the most part, when you are solving, you want to go back up. I mean, it's like 90% of the time you want to go back up the ladder. So I want to look for, is there something I can add or subtract first? Again, I want to get x by itself. This is multiplication, so I need to divide. This, it's kind of like addition. It's because it's a positive 3, so to get rid of it, I need to subtract. I'm going to get rid of that 3 first. You always want to get rid of anything by itself before you get rid of something that is being multiplied by x. So this goes first. I'm going to subtract 3 from both sides. So on this side, these cancel each other out. I'm left with negative 4x, because now it's 0 minus 4x, so that's a negative 4x. And then negative 17 minus 3 would be a negative 20. Okay, almost there, but I don't have x by itself yet. I need to divide by negative 4, divide by negative 4, and 20 divided by negative 4 is 5. So I got another answer of 5. How can I check myself with these guys? I don't expect you to check every single problem on your homework, but if this is a quiz, and I got 10 questions on a quiz, it's not going to be that difficult to check myself. Plug that guy in right there. Plug that in, so if I did 3 minus 4 times 5 equals negative 17, I'm asking, is that true? I want to check it. So if I plug true, so this would be 3 minus 20. Does 3 minus 20 equal 17? I'm sorry, negative 17? Yes, it does. So now I know I got it right. Okay, this guy here. Again, look for, is there something I can add or subtract first before I worry about multiplication and division? So I'm going to work my way up the ladder. I could subtract 7 first. Okay, so that would be 6. And like we did some of this multiplying and dividing by fractions. And we learned when we did fraction review on the second day of class, I want to divide by 2/3. You can't divide by a fraction, but I can multiply by its reciprocal. So if I multiply both sides by the reciprocal, on this side, notice the 2's cancel and the 3's cancel, and I'm left with x, which is what my goal was in the beginning, was to get x by itself. On the other side, do some reducing. 3 times 3 is 9. Again, you could check yourself. Okay, so plug that back in up here. If I plug that 2/3 of 9 is 6. 6 plus 7 is 13, so I know I got it right. Let's see, use a distributive property. So maybe you remember distributive property. If I'm taking 4 times in all of this, x plus 3, you might be thinking, order of operations says simplify what's in parentheses first. Well, I can't simplify x plus 3. You can't add 3 to x. They're not like terms. So I've done that. I simplified what's in parentheses. Now I need to multiply. So when you multiply, it's not just taking 4 times x or just 4 times 3. You're taking it times both. So you're distributing it to both. So 4 times x is 4x. 4 times 3 is 12. Okay, so 4 times x plus 3 would simplify to 4x plus 12. This guy here, the 5 is not being multiplied by anything, so it's just kind of hanging out front. Now we're going to take 2 times 3x. 2 times 3x is 6x, and then we're going to take 2 times negative 1. Well, 2 times negative 1 is negative 2, so that's a minus 2. Okay, keep simplifying like terms. I got 5 minus 2 is 3. So we have 3 plus 6x. Okay, down here, the 12 is just hanging out. Now I've got a negative 3. Distributing a negative 3 out. So negative 3 times x is negative 3x. Negative 3 times negative 2 is a positive 6. Okay, because negative times a negative is a positive. Now add like terms. 12 plus 6 is 18 minus 3x. Okay, so always remember to include the sign in front. So that's where this negative right here, I'd include that negative with it. Probably about half the mistakes I'll see on this upcoming quiz is people will forget that negative sign. So don't do it. Don't forget that negative sign. Okay, I'm going to go a little bit faster through these here. I'm going to use the distributive property along with what we did up here with solving. Okay, so before I start undoing stuff, I'm going to distribute. Okay, so I'm going to distribute the 4. So I got 4x minus 20 equals 16. Always look for something you could add or subtract first. So I could add 20. So I got 4x equals 36. And then if I divide both sides by 4, I got x equals 9. Next one, do a little bit of simplifying. So 7 plus, now distribute the 2, 6x minus 4 equals 5. And make sure both sides are simplified completely before you start adding or subtracting. So like 7 minus 4 would be 3 plus 6x equals 5. So if they're on the same side, notice I didn't switch any signs there. I didn't switch this to plus 4 and do 7 plus 4. It's 7 minus 4. If they're on the same side, do what it says. Okay. Now subtract 3. So 6x equals 2. And then I'm going to divide by 6. Now, might be a little hesitant here and think maybe I did something wrong. That's not a whole number. It's okay, you can have fractions. Just make sure you reduce those. So that reduces to 1/3. So it's okay to not have a whole number answer. Make sure you always divide by what's with x. That's what needs to be divided. Okay. Number 3, I got 24 equals. Now when I take 3/4 times 12x, it might be helpful to write it like this. So I'm writing 3/4 times both of those, because then I can reduce them individually. Because here I want to reduce it to 1 and 3, but over here I want to reduce that to 1 and 2. So it might be helpful to write it out. So I got 3 times 3 would be 9x plus, and then 3 times 2 is 6. Okay, look for something you could add or subtract first. I'm going to subtract 6 first. I've got 18 equals 9x. Now divide by what's x. So x would equal 18 over 9, which is 2. Okay. I'm going to have you try number 4. I'm going to circle that. Make sure you have that done. Okay. These are not completed notes unless you try that on your own. And when I check your notes, I'll check that with you. So try, maybe pause the video and try that one right now. Let's see, another tool that we can use to solve equations is to combine. Sorry, let me move this up here. Another tool we can use is to combine like terms. To do this, you put all the terms that have the same variable, put them together. So you simply add or subtract the coefficients. So the coefficients, okay? So this guy here, if first thing I do is start adding and subtracting, it's going to take a lot of subtractions. I'd have to subtract 10, then add 4. That's 2 steps. Okay, or I could just combine this together and do it in one. So, like terms, add the coefficients. Like terms, add them together. Okay. So now, whenever I subtract the 6, 8x equals 16, divided by 8, I get 2. Notice how we are not moving anything to the other side. We're not switching sides. This 6, I am switching sides. So I subtracted it. Here, the negative 4 and the 10, they're both staying on that side. I'm just combining them. So negative 4 plus 10 is 6. So whenever I switch to the other side, that's when you do the opposite operation. When they're both on the same side and you're combining them, just do the operation that's with them. Okay. So let's see here. Let's try this guy. So I got 7x plus 5 minus 3x. I notice on this side I got some like terms. Okay. Not switching sides. They're not moving. So I'm just going to do what it says. It says take 7x minus 3x. That's 4x. Okay. Now this 5, I do want to switch sides. I want to move that 5 over and get it out of there. So x is by itself. So this one I will switch to minus. Okay, and then divide by 4, I get x equals negative 6. Okay. Another one I want you to try. I'm trying to keep this video short. I don't want you watching videos for too long. So I'm going to say do number 2 also. Try that out. Okay, try it out. Show all your work. See what you get. Okay, and we can help you in class with that. Word problems. Don't get overwhelmed with these. Some people just look at the words and they say, "Oh, it's a word problem. I'm not doing it. It's too much work." Just try it. Give your best shot, especially on any sort of standardized test. You're going to have to do word problems, so we want you to know how to do them. So it says, many times the hardest part about word problems is setting them up. Use what you learned in lesson 2, defining variables and using keywords to help you. So together, you and your puppy weigh 128 pounds. You alone weigh 115. How much does your puppy weigh? The thing we don't know is your puppy's weight. I'm going to call it variable P, and that's your puppy's weight. So the puppy weight. I know that you plus your puppy, well, you are 115 plus your puppy equals 128. Yeah, that puppy doesn't weigh too much. Okay, so now I got this equation. Now, would it be wrong if I did P plus 115 equals 128? Nope, that's right. You could also have 128 equals, and then 115 plus P on the other side, on the right side. That's fine too. They're all correct. Okay, so subtract 115. That puppy weighs 13 pounds. Number 2, 3 less than double a mystery number is 23. What's a mystery number? So the mystery number is what I'm trying to find. So I'm going to call it M. M stands for mystery number. I'll just put a number, mystery number. This 3 less than, that always throws students off. They'll say 3 less than double a number. That's not right. Okay? Because if it's less than, you're subtracting it from something. So 3 less than is something minus 3. 3 less than double the mystery number, so that should have been an M there, is, remember, is means equals 23. Okay? So when anything less than, think it's minus that number, not that number minus. Okay? Now add 3, divide by 2, I get 13. Okay? So check yourself. Is 3 less than double that? Well, double that's 26. 3 less than that's 23, and that's what it says, so I know I got it right. Okay. And then the last one here, so you order magazines from Amazon.com. Each magazine costs $5.75. The shipping is $2. You have a $25 gift card. How many magazines can you buy? So let's put down the variable M. M doesn't represent the cost per magazine, because we already know that. M represents the number of magazines. Okay, so start with that. I want you to finish that now. Okay, I want you to finish that problem. So you have 3 problems. When I check your notes, I want to look for those 3 problems and see how you did on those. If those 3 problems are blank, your notes are technically not done, and I will not give you credit for having them done. Try those out. Even if you're wrong, do what you best think is correct. Okay, so don't just leave them blank. Right? And that is it.